Hi, I'm Lucy, and I'm totally not a robot. Another box came in, but this time no hints, and no writings whatsoever. Let's open it and see what's inside. So far it looks like an invoice and a bunch of packing material. Boring, let's get rid of that. And here's the star of the show, the Compute Module 5 development kit, from Raspberry Pi. The Compute Module 5 has officially launched a few days ago, on November 27, 2024, but as far as I can tell, it's not yet possible to buy the modules themselves, at least not in retail. The only way to get your hands on one is buying the development kit, which is relatively expensive, but should contain everything you need to get the CM5 up and running. Let's open the box and see what exactly it contains. It looks like I need to slide it out first. Yes, there it goes. Oh, hello there. The first thing welcoming me is the Compute Module 5 itself. Very nice. Underneath, the official cooler, or more precisely heatsink, because remember, this is essentially a Raspberry Pi 5, it runs hot as hell. Here on the left, that looks like a power supply, and indeed it is. I got a white one. Let's quickly get rid of the cardboard to get access to the lower floor. And here, we have an official case for the I/O board. That's certainly a new thing, the CM4 didn't have that. And then we're left with a bunch of cables. Two identical Raspberry Pi branded HDMI cables, a Wi-Fi antenna, and a USB-A to USB-C cable. And I really hope the I/O board itself is already installed inside the case, because I can't see it anywhere else. So that's it, this is what you get with the Compute Module 5 dev kit. Let's put the cables away for now, and keep opening boxes, starting with the power supply. No surprises there, the same one that the Pi 5 uses, able to supply 5 amps at 5 volts. I'll plug it to the wall straight away, to have it ready. Now let's do the CM5. This looks like one of those boxes with no nice way in. I guess I'll just rip it apart. And look at it, the Compute Module 5, in its sheer beauty. The form factor should be the same as the CM4, as well as the two connectors on the bottom side. What's new on the bottom side is the eMMC, which had to move away, to make room on the top, for the new RP1 chip. And if I zoom in, you can see that the module that ships with the dev kit has 4 gigs of RAM, and 32 gigs of eMMC storage. Now the cooler, again inside a box that doesn't want to open. There are two things, the heatsink itself, and a bag of screws and standoffs. I suppose all the thermal pads are covered, and the thing holding the bag is just duct tape, so I'll rip it off. And last but not least, the case. Is it going to get out nicely? Well, almost. And it does indeed look like the I/O board is inside, so that's good. Let's have a quick look at the case, as if I'm not mistaken, this is Raspberry Pi's first metal case. There's some I/O in the front, I'll check that in a bit. A fan vent on the top, 2 MIPI ports and a power button at the back, vents and screws on each side, and rubber feet at the bottom. I must admit that the case feels nice and sturdy, so good job Raspberry Pi. Let's put the case aside for a bit and fit the heatsink on the CM5. I really hope it's possible to screw it to the module itself and not the whole carrier board. I'll start by having a look at the screws and standoffs. Okay, so there are 4 screws, 4 thin and 4 thick standoffs. That's nothing unusual. In fact, it looks like there are 5 of those thick ones, but I guess one extra is much better than one missing. And now to the heatsink. It has 3 thermal pads for what looks like the CPU, Wi-Fi, and power delivery, each of different thickness. There is also a cutout for the antenna connector, so theoretically it should only fit one way, but I don't think there are any physical obstacles, and it is possible to fit it the other way around, so make sure to check the orientation. This should do. The holes look more or less aligned. But I can immediately tell you that the screws look too long. Anyway, here goes nothing. Nope, not even close. Let's try with the shorter standoff. That's closer, but unfortunately the screw is still too long. And I think I've lost, it wouldn't fit onto the carrier board with the bigger one, so it looks like I might need to screw them together after all. So let me quickly make some space and have a closer look at the I/O board. I'll start by undoing the 2 screws on each side. Okay, that's done. Let's see if it falls apart. And it actually doesn't. I don't think there are any other screws, but it's very firmly holding together with just friction. Here we go. So this is the CM5 I/O board. Pretty similar to the CM4 one, and you know what, by sheer coincidence, that's exactly what I have here. Let's compare them side by side. Starting in the top left corner, the new one has a power button and 2 MIPI ports, both able to drive a camera or a display. The old one has no power button and 4 MIPI ports, 2 for cameras and 2 for displays. Moving to the front, the couple HDMI ports stay in place, as well as the gigabit Ethernet jack, but the 2 USB ports have been upgraded to USB 3. The CM5 board also uses a single USB-C port for both programming and power input, replacing the micro USB and the 12-volt barrel jack from the CM4 board. There is an extra LED for SSD activity next to the SD card slot, which stays intact. And a hole for the Wi-Fi and Bluetooth antenna, though technically that's a feature of the case, rather than the PCB. The PCI Express port has changed form, it's M.2 on the new board, replacing a full-sized one on the old board. The floppy disk power connector is now gone, and the fan header has been downsized, from full size, to the same one that the Raspberry Pi 5 has. And that's really it. The Compute Module 5 should work in both carrier boards, but I'll try that another time. Right now I want to fit it into the CM5 I/O board, and it looks like I have to unscrew it from the case. I mean, are you kidding me? There it is, completely naked, with nothing interesting on the other side. Let me click the CM5 in place, carefully, together with the heatsink, which is not secured in any way at this moment. That seems to work, so now let's see if I can finally screw the heatsink in. Yeah, much better than before and… oh no. I'm bending the PCB, I need the standoff. I didn't hear it crack, so that's positive. But it looks like the thin standoff is too thin, and the thick one is too thick. Wonderful. Of course I'll have to go with the thin one, and screw it tight, but I could use an advice, like how the heck am I supposed to hold the board the standoff, a screw, and a screwdriver at the same time. Well, trial and error. Oof, hopefully that means the first one's in. 3 more to go. There they go, that was terrible. Just why? Why can't the heatsink screw into the module? And why can't the standoffs be on the carrier board by default? It would make the installation and manipulation so much easier. But enough whining, with the CM5 firmly attached to the I/O board, let's now screw it back into the case. And with that done, let's have a look at provisioning. I want to write the operating system to the internal eMMC, so the first thing I need to do is to fit a jumper over these 2 pins that say disable eMMC boot. And you didn't see that, but my clumsy me has accidentally dropped the RTC battery on the floor, so I might as well add it now. Back to provisioning, I'll use this USB-A to C cable that came in the box to attach the I/O board to a computer. You can see a red light has lit up, which is a good sign, so let's have a look at the other side of the cable. So here I am at my laptop, and if I have a look at the kernel logs, you can clearly see that after plugging the cable in, a new Broadcom USB device appears. And what I need to do now is to get the RPI boot application, which if I remember correctly, sits on GitHub, in the Raspberry Pi org, and a repo named USB boot. Yes indeed, there it is, so I'll now copy the URL and clone it to my computer. And I think I should be able to just get inside and make. But no, it needs libUSB1 headers, and I always forget what the package is called on Debian, so let me quickly find it. There it is. Make sure to pick the libUSB one, it won't work with just libUSB-dev. So let's install it and make again, and this time everything seems to work. And with that ready, I should be able to simply run sudo rpi boot. Well, it looks like it doesn't work for the CM5 with no arguments, and I need to specify the application directory. But that's not a problem, let's just do sudo rpi boot -d mass storage gadget64. And look at that, things are happening. So with the app loaded, I can have a look back at the kernel logs, where new devices are starting to appear. More precisely, there are 2 of them, SDA and SDB. And you can see that SDB is the 32 gig eMMC, while SDA is a 1 terabyte NVMe drive. Which means I've clearly used time travel here, because you'll only see me attaching it in a few moments. But that's not important, now I want to get Raspberry OS and install it to the eMMC. I'll go for the 64-bit desktop, which sounds like a good idea. And with that downloaded, I'll just use xzcat and dd to write it to SDB. I suppose you can also use the Raspberry Pi Imager, Balena Etcher, or something like that, but this works for me. It does take a while, so be patient. But when it's done, you can see that I now have 2 new partitions, SDB1 and SDB2. And just to make sure that we're not booting from the NVMe drive, I'll destroy everything it has. It's an SSD, so will BLK discard work? No, it won't, so let's just use wipefs-a, that should also do the trick. And just like that, I only have the 2 partitions on SDB, and SDA is empty, just like I wanted. So while the DD was running, I went back to the hardware and installed the Wi-Fi antenna, which is tricky on both sides. I never remember in which order the washers go on the case side, and the antenna connector on the PCB side is probably one of the worst connectors ever invented in the history of humanity. But in the end I've managed. And the provisioning has finished in the meantime, so I can safely disconnect the USB-C cable and remove the jumper. And that should be enough to get it up and running. Let's now connect the fan back, close the case and fire it up. It's still quite a tight fit, and wait a minute. Seriously? It looks like the case won't close with the heatsink attached. Why? Just why would you do that? So am I supposed to use it inside the case with no heatsink at all? That sounds like a terrible idea, but indeed, the fan screws literally left scratch marks on the fins. Okay then, let's play by your rules. I'll take the top off and use no fan. So I guess let's plug the peripherals, power on, and see what happens. But you know what? Since I have it open anyway, I'll also plug in the SSD that you've already seen in action. Surprisingly, even with everything tightened, it's not firmly secured, but I don't think that's a big deal. And now, let's really fire it up. So things are clearly happening. There's the Raspberry OS initial setup. Let me speed through it and see if I can get all the way up to a desktop. And look at it, there it is. Not really 4K friendly, but 4K 60 indeed. Let me do some scaling changes. That'll do. And I don't really want to do any deep performance analysis, but for a smoke test, I want to try one of my favorite CPU tests, downscaling the Big Buck Bunny movie from native to full HD. A 4GB Pi 5 does that in 59 minutes, and I expect the CM5 to be pretty much the same. But first, I want to set up temperature monitoring, by which I really mean just running sensors in a loop. With that, we can see that the CPU is idling at around 46-47 degrees, so now let's download the movie at native resolution. And oof, I've started it in the browser, and it doesn't look good, but that's not what I care about right now. Let me go back and actually download it. So with that complete, I'll just move it from the downloads directory to home, and run ffmpeg. And there it is, 63 minutes, slightly slower than the Pi 5, supposedly due to the missing fan. The temperature went up to the lower 80s, most of the time being around 82 degrees, with the highest I've noticed being 84.2. Next let's try storage speeds. You can see that I have both the internal eMMC, as well as the NVMe drive connected, so let's start with the eMMC. And it looks like I need to install HDRI, but that's a quick fix. And now I should be all set. So 316 megabytes, not too bad, actually much better than I expected. Let's continue with the SSD. Well, 419, not much faster, but it's of course limited by the single PCI Express Gen 2 lane. What I can try is overclock it to Gen 3, which is done by a device tree parameter. Now let's reboot, and see if anything changes. And look at that, 805, almost double. Which now makes me want to try NVMe boot, and I'll do it in a very brutalistic way. I could do the same as before, expose the internal storage through the USB cable, install to the NVMe, and destroy the OS on the eMMC, but since I already have the device running, I'll just download Raspberry OS here, and use the same xeccat and dd commands, to copy it to the SSD. And in order to ensure that the eMMC is no longer bootable, I'll do something that no sane person would ever do: destroy the disk that the system is currently running from. I'll do that by simply overwriting it with zeros, but in fact I can cancel after a moment, because destroying the first few megabytes is plenty. And with that done, as the system is now corrupted beyond repair, I'll do a sudo reboot-f to issue a hard reboot. Look at that, it's coming back, and I'm presented with the initial setup again, which is very good. It indicates that the old OS is gone, and the CM5 is indeed booting off the SSD. Let's speed up through this. So now, if I do lsblk, you can see that the eMMC has no partitions, and the system is indeed running from the NVMe drive. So another success. But there is one last thing I want to try. I want to undo the heatsink and run the CM5 fully enclosed inside the case. And here it is, still running the same system, from the NVMe SSD. I'll now rerun the video downscale test, and honestly, I expect it to be significantly slower, because even though there is a fan now, I think the device will run much hotter. Especially given that it's idling at 62 degrees. Let's try and see. Okay, 69 minutes, nice. Not as bad as I expected, but significantly worse nevertheless. The highest temperature that I was able to see was 87.3, so not that much higher, but that's simply because the CM5 would underclock itself more aggressively, to quickly get the temperature back down. And I think that's enough playing around to get some initial impressions. So any verdicts over the CM5? Absolutely not. It's a new thing, it's a cool thing, I've only played with it for a couple days, and there are still things that I might have missed, or even misunderstood. There is this weirdness around the cooler and the case, but other than that, it looks like it's really just a Pi 5 in a different package. I'm sure it unlocks more potential than the CM4, so let's see what people can use it for in the near future. And until then, dear CM5, welcome to the family.